Okay, today we're going to try to visualize suck, squeeze, bang, blow. We have a good example of an engine here that's half apart. It'll be a good visual aid to see what's going on. So inside an engine, there's essentially miniature explosions that happen many times a second, and that's what makes your car go down the road. These explosions are orchestrated using suck, squeeze, bang, blow. And we're going to talk about that right now. So if you look here, what we got here, I want you to focus on this bottom pulley. Inside there is a gear about this size underneath in there, and it's connected to this belt. Okay, and what that gear does is when you turn that gear, inside this engine is a piston that goes up and down in a cylinder, kind of like this: piston up, down, piston up, piston down. Okay, and what I have here is a long screwdriver, and in the top here, Toyota has made their spark plug hole in the very top of the engine, which is kind of neat. I've got the spark plug out, and I can poke the screwdriver through here till it sets on the head of the piston. So I want you to see what happens when I crank this wrench. Pay attention to the screwdriver. And I've got two pieces of tape here to mark what's called top dead center and bottom dead center. So right now, the piston, it's going down as I turn this. Now it's reached the bottom. And now the piston's going to come back up. And when I did that, this mark here on the pulley, once it hits 0 right there, the piston has done one complete down and up. So one full turn down here makes the piston go down and up. Does that make any sense? Okay. So this pulley is connected with this belt to a couple other pulleys, and this are gears and this top gear. Now these other gears here aren't going to matter as far as timing. This is a water pump. It doesn't matter. And here's an oil pump. That doesn't matter. And this is a tensioner pulley. That's just to keep the belt tight. But this, I keep saying pulley, sorry. It kind of looks like a pulley. This gear at the top is very important. It must be timed with the bottom gear. So this gear is important for timing valves, which is a very important part of the suck, squeeze, bang, blow. Now the suck, squeeze, bang, blow happens consecutively. So we're not going to start on the suck. We're gonna start when I got my marks lined up here, where it's on the bang. So right now we're timed. We're going to start with the bang. Actually, I'm lying. I need to go around one more revolution. Okay, this is something I should not have skipped over. So basically, I'm going to go around one more revolution, and I'm going to line this mark back up to 0. And now this is my other timing mark. Through this hole, there's a little white chalked mark inside there. So you got to think of this like a 10-speed. Now, when you're riding your 10-speed and your feet are pedaling in the front, your feet are pedaling slower than your back tire's going, right? So your back tire, and you can change the gears, and you put it the smaller and smaller sprocket you got on the back, the faster you go down the road. Well, the same situation's happening here in your engine. This gear on the bottom is smaller than the gear on the top. It's actually twice as small. So when I turn this one full revolution, for example, watch this mark. I'll go one full revolution on the bottom. See the mark? And I just did my full revolution. This mark went from the top to the bottom. This top gear's only gone halfway around, but the bottom gear went around one full revolution. So now I need to go another full revolution on the bottom to get my top gear back to the starting point. And that's very important for the suck, squeeze, bang, blow to work properly. Okay, so you see that this top gear turns twice as slow as the bottom gear. I got to go 2 full turns on the bottom for 1 full turn on the top. Okay, let's just do this. Makes sense. So I'd keep in mind that 1 full turn on the bottom makes the piston go down and up once. All right, ready? So we're going to start off with the bang. The bang is where a spark plug will ignite and you'll have an explosion. So what we have now is the piston at the top. And another thing I want you to see, can you bring the camera over here? Okay. Well, by the way, we're just looking at what's called the number 1 cylinder. This whole front part of the engine here is all your number 1. This would be your number 2, number 3, and number 4. Forget about 2, 3, and 4. We're just going to look at number 1, which is this whole front part of the engine. If you get number 1 timed properly, 2, 3, and 4 will be timed properly too. Okay, so this side of the engine is called your intake. I want you to see how clean it is. Well, if you call that clean. It's clean compared to the other side. I don't know if you can bring the camera over here or not. This is the dirty side. See how dirty that is? That's your exhaust, okay? So the good air comes in on this side, the bad air goes out on that side. Now, underneath here are valves that'll open up into that cylinder. And these lobes, when they rotate around and underneath there, they'll push those valves down. That's what opens those valves. So I want you to notice now that the intake lobes are up, the exhaust lobes are up, so all the valves are closed, which means the cylinder is tight. There's no openings. And this is where the explosion is going to happen. A spark will happen at this point in time, and what it's going to do is it's going to have no place to go, but it's going to force that piston down with pressure. And that's going to make, as I turn this, you'll see that this screwdriver shows the piston going downward from the explosion. Now, when that gets to the bottom, that's it. That's called your power stroke. That's the bang. Okay. Now notice here, these lobes on the exhaust, they're about ready to open up the exhaust valves. And as I turn this a little bit more, you'll see that at that point right there, the exhaust valves are completely open and they're ready for what's called the blow. So we just did the bang and now we're doing the blow. As I keep turning this, you notice that the screwdriver's coming up. That means the piston's coming up and the exhaust valves are open. So what it's doing is it's pushing the exhaust out your muffler at this point in time. And as the piston keeps coming up towards the top, now the lobes are moving past the valves and the exhaust valves are closing. Okay, so that's the blow. Now we're going to come into the suck. So now the piston's going to go back down, and when the piston goes down, it's going to it's going to suck air. And since it's got no place to suck from, you notice here the lobes on the intake side are now opening. So it's going to suck clean, fresh air in from this side into its area. And that's the suck. And now the piston's at the complete bottom, and that phase is done. And the lobes are just coming off the valves and closing the valves. See, now the lobes are off the valves. And now the piston is coming up again. But at this point in time, there's no valves open. You have a confined airspace in there. It's got that fresh, clean air and oxygen. If this is a carbureted system, that would be full of gas at the same time, but this is a fuel injection system. I don't really know at what point in time the fuel injector is going to squirt the gas in there. Doesn't really matter. But right now, the piston's going up, and what it's doing is it's compressing that air and pushing it tighter and tighter. It's the squeeze. This is called the squeeze. Okay, now the piston has reached the top, and now what we have is squeezed air with gas in it that is ready. And if you look down here, my mark is right back at 0. The bottom is actually turned twice throughout those 4 strokes. The top turned once, and we're ready to start over with the next bang. And there you go. You have the suck, squeeze, bang, blow. It's how to make a small explosion inside of an engine. The other cylinders are doing their own suck, squeeze, bang, blow at the same time, but they're not all banging at the same time. Some are sucking, some are squeezing, some are blowing. And that's so that you always have power coming from at least one piston all the time, so that your car doesn't stall. There you go. Does that make sense?
Sure.
Okay. Fantastic.